Right, ladies and gentlemen, I thank the organisers very much for inviting me, and thank you all for coming to this very important conference. I'm going to follow on from Joël and talk a little bit more about Adviclim, Adaptation of Viticulture to Climate Change Project, a LIFE European project. And what I'm going to do is give an update from some of my colleagues in Bordeaux Sciences Agro INRA, Geisenheim University in Rheingau, Yacht University in Cottenary, Plumpton College, of course, and the Centre National de Recherche Scientifique at Rennes and Brest. If you like, we're a sort of a group, a collection of viticulturalists, climatologists, and computer geeks. Working for the last 5 years, working towards predicting future climate change variability, simulating the impact of climate change on grapevine phenology and viticultural activities, and then eventually information transfer to the Viticulture Centre. I myself, as Jose said, I'm at Plumpton College, Centre of Excellence in Wine Education in the UK. However, Saint-Emilion have been doing this close climate change observation for quite a few years now. 90 temperature sensors, recording minimum, maximum temperatures for about the last 10 years, all with automatic data transmission onto their website. And they're gathering some really, really interesting information. Firstly, if we have a look at this one, this is the variability of the minimum temperatures during the 2016 vegetative season. You can see Saint-Emilion, the large hill, the Côte there, Libourne and Pomerol. The first thing you notice is the real big difference, the big amplitude. There's an amplitude of over 3 degrees in this minimum temperature. And, you know, it's within a small region like that. As you can see, it's about 15, 20 kilometers in size, in diameter. That's quite a lot. And if you take a transect through it like this, you see that there's a pretty good correlation between the minimum temperature and the altitude. So generally speaking, it's the lower areas near the river that tend to be cooler. If we look at the maximum temperatures, it's different. It's the opposite, if you like. Again, through the same transect, you see that the warmer temperatures are on the south-facing slopes. Anyway, you can take all this sort of information and plot it onto a Winkler index calculation. Winkler index is, for winemakers among you, I don't know, is a sum of the growing degree days of temperatures above 10 degrees Celsius in the region. And the striking thing about that is you've got an amplitude of 300 growing degree days within a small region of Bordeaux. And that's sort of really what kicked off the whole project, is that they discovered that there was more variability within one region than we think. In fact, more variability than between regions. I mean, 300 is about the difference in general between Bordeaux and the Loire Valley. So it's quite significant. This is as you can imagine, the warmest areas are where the most important chateaus are on the south-facing slopes. In Rheingau, in Geisenheim, they've also been doing this project for a long time and getting sort of similar results, or similarly interesting results. They've had 31 temperature sensors, and the interesting thing about Rheingau is they are totally working on Riesling, so the results are very comparable. The other thing is that there's a really big difference in altitude. So they're working from, the Rhine is at about 100 meters altitude at that point, on a very, very steep slope, going up to 300 meters in a couple of 100 meters. It's pretty spectacular over there. Again, you've got quite a big temperature variability. This is the April to October mean temperature, about 1.3 difference. And you can see the warmer areas are downstream on the lower slopes, on the steeper slopes as well, whereas the cooler areas are in the hinterland. And they found a very good correlation, or well, a pretty good correlation, okay, 0.63, between the temperature and the altitude. So there's a decrease in temperature with the increase in altitude of about 0.55 degrees per 100 meters, which is pretty classic. That's reflected in the data flowering. So in 2016, you can see there that the flowering is closest at the lower end of the valley. And there's a difference of almost 2 weeks between the flowering, full flowering in those regions and those behind for the same variety. And that's reflected in all sorts of data. For instance, the sugar contents or total soluble solids content on the 21st of September is also sort of markedly different according to the different part of the region itself. We've created climate models of these. So this is, for instance, a model which has dissected or influenced the Huguelin index. The Huguelin index is similar to the Winkler index, and again you can see how very, very important the position of a vineyard within a region is, and how much difference that actually makes. Our friends in Romania have been working slightly different model. They've got a model called climate suitability for different vine varieties, which ranges from 1 till 10, with the map on the left-hand side showing the climate suitability between 1961 and 1980. And there you can, and the yellow and orange are suitability for white wine production. And what they've noticed, which is very striking, is using their model, there's been a very large shift between the averages of 1960 and 1961, 1980, and 1981 and 2013 towards the red varieties. So that if you look at this table here, on the left-hand side, you see that in the 61-80 period, the Cottonari region was 87.9% suitable for white varieties, but in the last 30 years, it's switched dramatically to being 60.6% suitable for red varieties, which is a pretty big change. They've also, using the Eurocordex database, predicted the evolution of the Huguelin index for their region. And again, the results are showing that that region of eastern Romania is switching from a white wine-producing region into one of red, and could get even warmer than that. Our work at Plumpton College has focused on an even smaller region. These are our main vineyards at the college. Pondfield is just 1 hectare on the left, and then Deerfield on the right is 4 hectares. And we've got 19 sensors in there, recording minimum maximum temperatures every hour. And again, we've been struck by the difference in performance of all these different sensors. If you look here at the cumulative growing degree days, or if you like, Winkler index, there's a really big spread within what's quite a small, really a very small vineyard patch. So we tried to understand what was causing this. Well, first, actually, we mapped it, actually. We mapped the Winkler index over the whole field. And you can see the sort of pond field on the left is pretty universally warm. But the variations within Deerfield on the right are staggering. I mean, here we've got Winkler indexes which are going from 1,000, which I've got to say for England is pretty good, right down to below 800, which is where it becomes very difficult to ripen grapes. So we tried to understand why these changes occur, looked at altitude, for instance, and altitude certainly plays a part. though even though the altitude difference isn't that much, it's only about 30 meters, it's not like Geisenheim. But here we're getting the opposite phenomenon to what they saw in the Rheingau. We're getting the cooler regions are the lower ones, and the warmer regions are higher up, generally speaking. We also had did some very sort of precise GPS measurements, had a look at the orientation, and we noticed that within a field that looked pretty uniform, there were lots of different orientations, and this whole band across the field that faces east, for instance, and also the slope. There was quite a large variation of slope within one region, if you really look at it in a lot of detail. We've analyzed these sensors and trying to make some sense out of this data. It's not straightforward. Obviously, one thing that, as I say, we did find was this very close relationship between altitude and temperature, with us going the opposite, if you like, to what was happening in Germany and in Saint-Emilion. We tend to have warmer temperatures at higher altitudes. The project has worked on mapping UGLA index at a regional area, of course, but really what we're specialists in is working at very small scales. So this is the sort of projections for UGLA index, different regions. These are the 6 regions we're working with, according to different scenarios, RCP 4.5 and RCP 5.8. That's all sort of been done before. What we're good at is taking the resolution on the right-hand side, which is the one that most people work with, a resolution of 8 kilometers per data point, and actually modeling it to 25 meters. So our computer guys can go to a precision of 25 meters without too much of a problem. So the interesting thing is then we're going to feed this information into a very clever model called SEV. And SEV sort of integrates grapevine characteristics, phenological developments, topographical characteristics, climatic characteristics, even disease characteristics. And we'll generate, for instance, different grapevine phenological phenomena. Yeah, 3 minutes, I'll be finished. Grapevine phenomena. And so we will be able to say, according to different scenarios, according to different varieties and the different vineyards where flowering will be, veraison, harvest, and so on. But also what we'll do will be to use this data to produce a model, if you like, a decision support system that will take in climate data, phenology, production systems, topographical data, and generate a system useful for vine growers, which takes into account climate data, plus predictions, phenological observations and models, life cycle assessments, like carbon cycles and energy cycles, and also environmental and economic impacts. Or at least that's the aim, anyway. We'll, for instance, be able to use this sort of model to simulate the impact of adaptation responses, like the one that we've seen in previous presentations. So in conclusion, we've discovered, if you like, that any climatic analysis and modeling at the global scale and regional scales are not really accurate enough for vine growers. We're looking at a very, very local scale and working at that to improve adaptation, to allow creating an improved framework for developing adaptation options. And so we're going to generate climate and phenological models adapted to the vineyard scale, integrating climate change scenarios, and then eventually transfer that to the viticultural center. So that's our website, adviclim.eu. And I said we've generated a lot of results. At the moment, they're still pending publication, so I can't present a lot of them, but they will soon appear on our website. Thank you very much for your attention.